Okay, so now that we have gathered our key points and our transformed key points along with our vertical asymptote, we're just going to take all that information and now sketch our graph. When I'm sketching my graph, I always like to start off with graphing my vertical asymptote. As you guys can see, I just changed my pen right now because it's more clear for you guys to see. Okay, so vertical asymptote is 3, so it's 1, 2, 3. And I'm going to just draw my vertical asymptote right there. And my key point for my transform function is 4 and 4. So this is 4. And we need to go all the way up to 13. So I'm just going to go ahead and just plot my point on the x-axis all the way up to 13. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and our y value is going from 4 to 6, so I just need to make sure that I have the value of 6 in there, as well as a little bit further on, because logarithmic function does essentially increase at a slower pace. So it's 1, 2, 3, 4, 5, and 6. Just writing down my key points. This is the x, and that's the y value. Okay, so first point would be 4 and 4, so 4 and 4 right there, and I have 13 and 6, so 13 and 6. So using that piece of information, I'm going to go ahead and just graph my function. It's an increasing function, a very slower pace. So this right here is my transform curve, and I'm just going to now label it as 2 log 10 x minus 3 plus 4. Alright, great. So now that's completed. We're just going to carry on and complete some of the other parts of the question. So part C says, state the equation of the vertical asymptote, and we did that several times in part A, B, and we're just going to go ahead and just formally write it right now. That's the equation of the vertical asymptote. State the domain and range, and we're going to refer to the graph to state that. As you can see for my domain, my function is only greater than 3 for my domain, and for my range, it's a set of all y values. So just writing that in set notation, x such that x must be greater than 3, and x is an element of real numbers. And then for my y values, which is my range, it covers a span of all y values, so there's absolutely no restrictions there. So y such that y is an element of all real numbers. Okay, good. And then part E, it says, if 102 is a point on the base graph, state the coordinates of the transform point on g of x. So I'm just going to go back to my original point there and then be able to transform it. So I'm going to refer back to part B to be able to do part E. So if my point is 102, what would my transformed functions would be? Transformed points would be, so that's 100 plus 3, which is 103. And then 2 times y, which is, 2 times 2 is 4, plus 4 is 8. So my new point would be 103 and 8. All right, and that's it for example number 1. Thank you.